The next application of derivatives we want to take a look at is the idea of elasticity of demand. So before we get into calculating it, answering some problems, we want to talk about what is this idea? So what is elasticity of demand? So if we recall that revenue can be calculated as price times demand, this means there are going to be two different ways to increase a company's revenue. And those two methods are either increasing price or increasing demand. So if we increase price, our revenue is going to go up, but in response to that, demand is going to go down. So basic principle of economics, the more you charge for something, the fewer people who are going to be able to buy it or be interested in purchasing it. So we can increase price, but we have that effect on demand. The other option is to increase demand. So somehow encourage more people to want to purchase the item. The problem there is that demand is very difficult to control, since obviously we can't directly influence what people are going to buy, we can only attempt. So demand is going to be difficult to control, which leaves us with price as the only thing that's relatively easy to control. So our one method really for controlling demand is to drop the price of our item. So what this means is we have two scenarios. If we increase the price, we'll decrease demand. If we decrease the price, we should increase demand. But the question that we need to answer is, what exactly a change in price will do to demand? So if we increase our price and drop demand, are we making more money? Are we making less money? Same thing with decreasing our price. Are we going to end up making more revenue, decreasing our revenue? So what we want to look at is how we can calculate the change in demand. So if our price changes by some percent, let's say C percent, so it could increase by 5%, decrease by 10%, then our change in demand can be calculated as E of P times that percent change in our price. And in that expression, E of P represents the elasticity of demand at our current price point P. So essentially there's a number that we want to calculate. We multiply that by that percent change in our price, and that's going to tell us what's going to happen to our demand. So to interpret that, we'll either get a value for E of P, that elasticity, that's between 0 and 1. We'll get a value for E of P that's greater than 1, or we could get a value that's exactly equal to 1. So what we want to know is, what do each of those different cases mean? So if E of P, that elasticity, is between 0 and 1, that would mean, say we have a 10% change in price, a 10% increase, times some value for elasticity. Let's say 0.8, that's a value between 0 and 1. That means we would get, as a result, 0.08 or 8%. So what we're saying is that if we increase price by 10%, demand will decrease by 8%. So overall, that's good. We're selling fewer items, but we're selling overall for a higher price. So we refer to that as inelastic. So our change in price results in a smaller change in demand, which is a good thing. If we're looking at values where elasticity is greater than 1, then if we look at that same 10% change in price times, say, 1.2, any value larger than 1, then we get, as a result, 0.12 or 12%. So increasing our price by 10% decreases demand by 12%. So our increase in price yields a bigger change in demand, which would be bad. So we would refer to this demand as elastic. And our last case is when that elasticity value is exactly equal to 1. We call this unit demand, because if we look at, again, that same 10% change in price times an elasticity of 1, we get a 10% change in demand. So our change in price, our increase in price, yields exactly the same decrease in demand. So overall, our revenue is not affected. So in each of these cases, we want to think about what we could do with price to affect our revenue. So here, in that inelastic situation, an increase in price yields a smaller decrease in demand. So if we increase price, we'll increase our revenue. In the elastic situation, our increase in price yields a larger decrease in demand, which means that if we increase price, we would actually decrease demand. Or the other way to say that would be if we decrease price, then we'll increase revenue. And this idea of unit elasticity is essentially the same thing as our optimal price point. If we increase or decrease price, we see exactly the same change in demand, so our revenue is not affected. So by taking our elasticity and finding when that's equal to 1, that price point gives us essentially the optimal selling price for our product.